Hey students, I was just driving home and I thought of a quick little trick to find the secondary solution to your trigonometric equation without having to do the geometry stuff we were doing, but just by knowing a little formula, a little trick. So this is something that might be hard to memorize, so it's still good to know all the the geometric unit circle reflective way of finding that secondary solution to a simple trig equation. But this little trick is nice and is a really good shortcut that we can use our calculator to help us do if we get it. So I've put right up on the screen there the trick that I came up with. So for cosine, if we use the inverse function to find our first theta, so what I wrote is theta sub 1, our first angle, if we just take the inverse of, we can find that first solution. And then the secondary solution is what I'm saying is theta 2. Basically, to find that, we can either take our inverse answer and subtract it from 360, which will always work, or from 2 pi, depending on if we're in radian or in degree mode. So essentially, if we have cosine theta is equal to something, or that something, is in between, has to be between -1 and 1, because cosine is undefined for those other values. Basically, we take our inverse function to find the secondary, simply take it away from 2 pi or 360. With sine, very similar trick, not quite exactly the same though. If you take the inverse of both sides of your equation, you'll get one solution based on the inverse's restricted domain and range. And then the secondary solution is going to actually be, how we said it's reflected about the y-axis. For sine, it's reflected about the x, cosine is reflected about the y. But basically the trick for sine is, instead of having to figure out all those reflections again, you basically take your angle, you take your first solution, subtract it from 180 or from pi, and that'll get you that secondary solution for. And tangent, we already talked about, but if you find your first answer with the inverse function, you just add pi to it or add 180 to find that secondary solution from there. So keeping that in mind, let's look at a couple examples. And again, this is supposed to be a shortcut so that we don't have to do all that other stuff towards finding our other solutions. But let's say we had sine theta is equal to 1/2. So basically, instead of having to look on our unit circle, we could just take the inverse function and find our first solution. So the first solution would be the sine inverse of -1/2. So if we do that, sine inverse of -1/2, actually I've already done it over there. I'm in degree mode, so our first solution would be 30 degrees, negative 30 degrees. Oh no, sorry, sine inverse of +1/2, positive 30 degrees. So that's our first solution. And so that's, calculator gives us one. Well, how we used to find the other was reflecting it, but here's the shortcut instead. So back to the shortcut over here. The shortcut says our secondary solution, theta 2, is 180 minus our first, or pi minus first. Since I'm in degree mode, our second solution is going to be just 180 minus 30, which is, of course, 150. And so, that's a lot faster. We can get our two solutions, 30 and 150, quite a bit quicker. And if we look at those two angles, 30 and 150, they both have a sine of 1/2. So checks out. So let's say we had a -1. Let's say we had sine of theta is equal to -0.9. And of course, this isn't a unit circle value, so there's really no option besides the calculator. So if we take the sine inverse of -0.9 here, using our TI-83, we get, -64 whatever degrees. So if we estimate that, I'm just going to round it to approximately -64, just the nearest whole, -64 degrees. So again, using the trick, our secondary solution, instead of having to say, well, that angle's down here and the other one is going to be over there, instead of having to do all that, we just use our trick. So we take our first solution, and the second solution is going to be 180 minus the first solution. So 180 degrees minus -64 degrees. And again, notice that since our first solution was negative, when we subtract it from 180, it actually turns into a plus. So we're going to end up with 244 degrees approximately as our secondary solution. And if we look at those two positions, we can sort of see if those seem to make sense. But if I draw a little unit circle right here, so negative 64 would be down here about, and 244 would be in quadrant 3 because it's not quite to 270, would be right there. And those two both have the same sign. They both, well, they just upon inspection here look like they could be both negative 0.9. Again, we could plug those two angles into our calculator to make sure that those indeed work in the equation. But if we or we can, you know, if we're answering from 0 to 360 as a positive, we could add 360 to that guy, and that would give us two, what would that be? Plus 360 would be 296 as a positive angle. So, you know, if we're looking for that specific interval, we'd have these two solutions, which, of course, that 296 is coterminal with negative 64. So we get those two answers, which should also work in the equation. So let's see. Let's also do a quick example of cosine, and then I got to run. So if we do cosine now, so let's say we had cosine of theta is equal to root 3 over 2. Let's do negative root 3 over 2. Again, we could use a unit circle, but again, the trick is so that we can save some time and just do it without having to do all that examination. So if we use our calculator, we take the cosine inverse of negative rad 3 divided by 2. Gives us 150 degrees, as we should expect. And you know, with cosine, the x-coordinate, if we're matching the x-coordinate on that, we would know how to, you know, we'd expect what to get from that. But if we look at the trick over here, it says that our first solution is the cosine inverse of our not our angle, but our value a, which in this case we're solving cosine is equal to negative rad 3 over 2. So the secondary solution is going to be subtracted from 2 pi. So with sine it was 180 minus the first, or pi minus first. With cosine it's 2 pi, or 360 minus the first. So our second solution is going to be 360 minus 150, which is of course 210 degrees. And that gives us that other solution to the equation. And if we graph these on a makeshift unit circle here, so 150 degrees is right there, 210 degrees is right there, and of course those have the same cosine. They both have a cosine of negative rad 3 over 2. If we look at the x-coordinate at that position, it's the same x-coordinate, so bingo bango works, and you could do the same for other things as well. So hopefully you found this little trick useful. See you guys in class. Bye.